d by dx equals 2y squared all over x squared plus y squared. This is a homogeneous first order differential equation. So let y equal vx then, or in other words, v equals y over x. So we can also write that down. So divide by x squared top and bottom. So we'll get 2v squared on the top. Divide by x squared on the bottom, we'll get a 1 here, and we'll get a v squared there. So that's what we've got. Let's get dy dx then. So dy dx is equal to product rule. So it's u dv dx, which is 1 plus v, times du dx, which is dv dx. So we've got a v plus x dv dx then. So substitution gives. So let's see what we've got. Dy dx we can replace by this here, v plus x dv dx, and we know that equals this stuff here, 2v squared over 1 plus v squared. Right, well let's move that v over to be with the other stuff on the right hand side then. So x dv dx is equal to 2v squared over the 1 plus v squared minus v, which I'm going to write as v times 1 plus v squared over 1 plus v squared, like so. So x dv dx then is equal to 2v squared minus v minus v minus v cubed all over 1 plus v squared. Right, so what does that give us then? So let's separate the variables then. Separating the variables gives, let's see what we've got then for the integration. So the equal stays what it is. The dx comes up, the x goes down from times on the other side to divide on that side, and on the other side this 1 plus v squared comes up to the top, and there's a v common here, so let's take that outside of brackets. And I'm going to take a minus outside as well, so I can flip these all around. So it'll be v squared. Then it'll be plus 1, or I'll write this one second, minus 2v. And then it's plus 1, isn't it? So that would be plus 1. That's it. And this is v minus 1 squared, isn't it? So we'll end up, I'm going to move this minus over there, just to get it out of the way. So we've got v squared plus 1 over v times 1 v squared minus 1. V squared minus 1, isn't it? dv equals minus ln x, just do the integration now, plus k. So, okay, right, so this would be v minus 1, v plus 1, v minus 1 squared. Sorry, I've written a 2 in the wrong place there. That is actually v minus 1 bracket squared I meant to write there, I think. But that's what it is. Okay, good. So we've got that. So we need to do a subproblem to get the partial fraction. So here, v squared plus 1 over v minus 1 squared is equal to a, it's a proper fraction, so it'll be a over v, plus b over v minus 1, and then plus c over v minus 1 squared, won't it? So let's see what we get here. So v squared plus 1 on the left, multiplied by the denominator, we'll get a v minus 1 squared plus b v times v minus 1 plus c times v, isn't it? So put in v is 1, and that will give us 1 squared is 1 plus 1 is 2. These will be zeros here and here, because this will be 0 and this will be 0, and we'll just be left with 1 times c. So c is 2 then. Okay, that's good. C is 2. Now, what should we do now? Compare the constants term. So the constants, 1 on this side will equal, there'll be 1a there, which is a. This will be 0, and this will be 0, because there's no constants here, are there? So a equals 1. And next we shall compare the v squareds, I think. Would be the next best thing to do. So one of those here will equal a of those there. And there's just a b there. There we go. So b is equal to 1 minus a. A is 1 minus a, and a is 1, so that's b is 0. So b is 0. So now what have we got then? We can replace the integral that we had by this thing here. Here's the integral that we had, and we can replace it by a, which is 1 over v, plus c, which is 2 over v minus 1 squared. Okay, so let's do that then. So let's go back to our original problem then. So the integral of this thing that we've just mentioned, just above, I'll bring it back into view. A is 1, so it's 1 over v. So let's just put that in there. 1 over v plus b is 0 plus c, which is 2 over the v minus 1 squared, wasn't it? dv. I'll just show you that above now. See it? 1 over v plus 2 over v minus 1 squared equals, and it was minus ln x plus k, wasn't it? On the right hand side. So that's what we've got then. There's our problem now. So this is okay. This is log v. This is plus 2 lots of, but I'll just write down, this is to the power minus 2, so I need v minus 1 to the power minus 1 over minus 1 times the 2, and that should do it, shouldn't it? Because if we differentiate this, something to the minus 1, minus comes down, cancels with that to the minus 2, multiplied by this differentiate, which is 1, and it still leaves the 2 there. So this makes a minus here, so I just put that in there. So the 2 stays as it is, with the minus makes minus 2, so I'll put that in there. Like so, and I can get rid of that line as well. Okay, so we've got that is equal to minus ln x plus k. And now at long last then, put our y over x back in. Log n of y over x minus 2 y over x minus 1 to the power minus 1 is equal to minus ln x plus k. There we go.